Semiconductors can be classified into two types. One is intrinsic semiconductors. Another is extrinsic semiconductors. So, intrinsic semiconductors are the semiconductors which are pure. Intrinsic means its another name is pure. Example, it is silicon, germanium. It is homogeneous. If you find silicon all over the crystal lattice. Everywhere it is silicon. Whereas extrinsic semiconductors are impure semiconductors. You are adding impurities to the intrinsic semiconductors. You get extrinsic semiconductors. The process is called doping. By doping, you can have two types of extrinsic semiconductors. First one is N-type semiconductors, another is P-type semiconductors. Here trivalent impurities are added, here pentavalent impurities are added. Here electrons outnumber the protons, however they are electrically neutral. This is electron rich type of N-type of semiconductors. Here number of holes will outnumber number of electrons. As you all studied in the class how holes and electron pair is formed. So N-type semiconductors where number of electrons is more than number of holes. However, it is electron rich but electrically neutral because it is a basic feature of every atom. P-type of semiconductors is trivalent. Number of holes is this case is greater than number of electrons. However, if you go to a N-type semiconductor, its electron rich such that its energy will be just below the conduction band. This is called donor level. And somewhere here if I consider the valence band. Whereas for the P-type, if this is a conduction band, the energy will be just above the valence band and this is called acceptor level. So, there will be a barrier, there will be a difference in the energy of the donor level of the N-type semiconductor and acceptor level of the P-type semiconductor.